Thank you, everyone. My name is Deepak, and I'm currently working as a staff software engineer at PayPal. Uh, and Akshay and me sits on the same floor, actually, so from the PayPal side. So this talk is inspired by latest Kubernetes release 1.36, where they went a new feature into GA for the user namespaces, and I thought to give it a try and maybe share my learning with you guys. As a question, this talk is not about how to run privileged containers or how not to run privileged container, but to share my learning and experience how I played with this particular feature. And also we will learn what actually privilege means here, because sometimes you just get confused between running a pod as a root versus privilege escalation. We will learn a few of those as well. And maybe some ways how to reduce this kind of risk if we have to run privileged containers. Talking about privileged container as a recap, you can specify your container to run as a privilege after specifying the security context privilege true under your container spec in your pod. And what you get in return, your container gets almost all the Linux capabilities behind the scene. You can access any of the devices attached to your nodes, and you can essentially modify the kernel behavior as well if you have this privileged container access. And you almost get near root kind of access on the host system as well. So this particular option has been an issue for the security researchers as well, security engineering folks or so. So you will always see the AIs folks or the security engineering folks recommending not to use, or they don't allow this feature to be used actually, unless there is some critical workload. Let's say you have a networking plugin that still needs to have some privileged access to modify the underlying networking host networking. So in those cases, you may need this feature still. Sorry. Taking a recap on what actually happens at the host level or the Linux level when you spin up a pod. For each pod, your container runtime actually try to spin up few Linux namespaces. That's how the Linux actually isolate your workload. At a high level, it creates 5 to 6 Linux namespace for each of your pod. At time, image space is usually being driven at the host level because you want your pod or container to have the same timestamp as your host. But other than that, usernet, UTS-IPC, mount PIDC group is what you want isolated from your host system actually. Talking about root versus privilege, as I mentioned, sometimes users get confused about roots versus privilege. If you are running your container as a root, that does not necessarily mean you have the privileged access to it. So this table outlines some of the differences between if you are running your pod or a container as a root versus if you have specified the privilege flag true. If you are running as a root, usually you get a user ID 0 and the group ID 0, which represent the root in your container. That's happened with the same as the previous container. So when you specify any specific privileged container a true flag, what happens behind the scene actually? The container runtime sets a no new privilege flag to false. That's how this particular functionality at the kernel level is implemented. If you have privileged container, you almost get all kind of access, Linux capabilities, networking, and you can have a host escape risk as well. We will learn one of the CVE that is covered due to this particular privileged access mode in one of the cloud provider. Okay. So as a default behavior, when you don't use user namespace level isolation, or when you run a privileged container, what you get behind the scene is On the left side of the panel, you are seeing the list of the Linux namespaces and their user when you SSH into a pod. So you can see I'm running a simple command sleep infinity using a busybox container image, and all these namespaces are owned by the root. This root user is inside your container users and the group. But when you go to your host node or the control plane nodes, you try to filter out that the same container process using the CRI/CTL. You will see that even though the process in the container has the PID one, it is actually mapped to a different PID at the host, but still you have the root user running those commands there. So essentially, the root user in your container is mapped to the root user on your host when you specify privilege true. That's where you can escape your container and try to execute some of the root level command, like setting some GID or the UID bits on your binaries. As the main issue that the security folks has, usually you can try to execute some of the root level command on your host operating system and try to bypass container level isolation at the host node. Talking about user namespace feature, so this particular issue was addressed by this particular feature flag called user namespace support. It was first introduced as an alpha feature in Kubernetes version 1.28, and it recently went into GA in the version 1.36. What you have to do is actually you have to set host user flag in your pod specification to false. What that feature does, if you specify host users to false, your container user ID and the group ID are not mapped one-to-one to your host username and the group ID. They map to a different ID. We will learn just in a minute that. So as a process of that, what happens behind the scene, even your container is running as a root, in the host system, it is treated as a non-root user. And few of the CVE which was fixed for this particular feature was, there was a CVE where you can actually manipulate the kernel behavior or RNC behavior outside of the container. And one of the highly highlighted CVE was in the Azure Escape. There was a area service in the Azure container instances. So what few researchers did, they escaped the containers running on the node, and they were able to view the containers on the separate node. So how the Azure container instances does behind the scene is, you get the isolation boundary is the node level in the namespace. So on a particular node, only your instances will be running, but on other node, there may be some other customers running their pods. So the security researchers were able to jump outside of their container or the node and be able to view the containers running of the other customer on the other node. So this particular feature, which was added by the user namespace support, actually eliminates those kind of issues. Now, if you run a pod with a host user false, what happens behind the scene, even though you are running your container with a root user, you can see I have a field specifier as user 0, but I'm specifying host user. What happens behind the scene, your process which is viewed by the host operating system, it maps to a different user. Look at the user ID, it is some very big number, 2668691, right? So what happens behind the scene, the Kubernetes or your runtime does not map to a non-root user, it maps your user to a non-user beyond the user ID of 6356. That is the default number that is being used with the group ID and the GID. So if the Kubernetes would have mapped that non-root user to some user between the range of 0 to 665, then maybe there exists some user with the same group ID and the name on the host operating system. In those cases, that could essentially uh, use those user permissions. So what happens, 0 to 655 ID range for the group ID, and the user ID is reserved for the host one, and the runc uses a separate range above the 655 to map your root IDs to a non-root IDs. So as you can see on the right side, it is your process running on the host node with a different PID, but also a different user. That's how these user namespaces are isolated, and you get a complete isolation between the process running as a root inside the container versus the process running on the host operating system. Uh, Obviously, there are some limitation at the moment. There are some work in progress already. If you use host user host, at the moment you cannot use host network to flag. There is some work in progress uh, already in place. Maybe in coming release you can use host network. Host IPC you cannot use as the moment, and as some other are limitation. There are some work already going on, as I mentioned. So in the future, maybe there is better isolation. In some cases, the user wants to use this feature as well, as there are some ANI provider or the storage provider which need this kind of like privileged access on the host operating system. So we may see those in the future as well. Thank you. Yes, sir.
So why are only implementing those in straight mode?
It's just a sample pod running with that particular command. You can have any other pod with a code running, but the idea was to show if, irrespective of what command or what language you are running, it actually what privilege you have inside your container. So you can have sleep infinity. That's just a sample command. You can have any other command running. Yes, sir.
If you have a privileged container, does it make a difference whether the user is root or not root or whatever?
Root, having a root. So as I have at this one right here.
Yeah, you had that, but like
right.
There's also what if you have like non-root user plus privilege and non-root user plus not privilege?
So if you have a privilege true, what happens behind the scene? Your user is mapped to a root user on the host operating system. So if you have a privilege flag true, you essentially have the root permission on the on the host operating system, and then you can essentially exercise those privilege permissions. So how this particular feature is implemented privilege true? So Linux kernel has a flag called for the kernel level, no new privileges. That means if privilege is true, then that no new privileges flag is false. That means your container user, container process can use more privileges on the host operating system. Now there is two flag called privilege true and allow privilege escalation flag true on the security context. When you have privilege true, you by default has all the admin level permission on the host operating system.
Okay.
Right. So it like yeah.
Okay, thank you.
Given the lot of AI abstractions right now, I don't think anybody is really looking into this run as user, like small little config changes. I know the CVE became very popular. Everybody are like behind it, trying to figure out how we can stop it. Do you have any idea? Is there any implementation that you have done for the future? Because more and more we are turning into AI. We're not really looking into the code, and this is going to be costing everybody a lot.
See, these kind of controls are actually needs to be enforced as a security guardrail. So even though you have more of a AI writing your code, you still need to have some guards in place. So as this is a very new feature, right? So actual implementation guideline, maybe some new CVE come around, how they implemented this particular feature may arise in the future, but Yeah, I don't know.
I have an answer to that. So there's this product called Edera, EDERA, that provides some defense in depth against this kind of attack. However, it's a proprietary premium product, basically. So if you have money and you really want to be like paranoid against this kind of container escape attack, you can pay them. Some of the people that have developed that product are very sort of sharp and kind of well connected in the kind of container security space. So
echo that. Big fans of Adera and the supporters or founders of them. I have a separate question. I was wondering if you could remind us about what host IPC, host PID, and host network privileges do.
Okay, so coming back to this one, right? You are asking about the UTS IPCO, right? This one.
What does host PID, host IPC, and host network be enabled to true do? For a particular product?
So this one,
Yep.
yeah.
Yeah.
So host, so I know about two or three. I may not be expert, but I can walk through. Host network is when you can essentially communicate with your host network as well, right? Host IPC, if you want to talk to some processes running on the host PID essentially, if you can view or interact with any other process. I think I'm not fully confident, but looking at the name, it can go. Yeah.
Yeah, I think it means like I kind of make it familiar to me that or can use the host IP addresses and stuff to communicate rather than doing the Kubernetes IPs.
Yeah.
Using ECO rather than use that.
Right.
Do you know why NFS volumes can't be mapped?
Sorry.
Because of the host user namespace?
Sorry. Sorry, I could not get.
Do you know why the NFS volumes can't be mapped because of the host user namespace?
So when the these runcs or the containerd actually create your process on the host operating system, actually, what they do, they actually, at the moment, these binaries or the process actually need some admin privileges at the moment. That's how they map your host, I will say host root file system to your container file system. These binaries are still a bit behind on these particular features. Those